Alright, welcome to the Unit 8 review for Algebra 1 Honors for quadratic equations. So if we look at number 1, solve the quadratic equation using square roots. If not possible, explain why. So we're going to start by getting the squared term by itself by dividing by -3 to both sides. So x squared is equal to 25. Then we can take the square root to cancel it out. And x is equal to positive or negative 5 because the square root of 25 is 5, and we know that there are always two possible solutions to a positive square root. Number 2, 5x squared is equal to negative 125. We're going to start the same way. We're going to divide 5 to both sides. Cancel those out. X squared is equal to negative 25. And now we're going to take the square root. Those cancel. X is equal to... Now, if we try to take the square root of that, we know that up above it was positive or negative 5 because it was a positive square root. But this time, because we have a negative under the square root, and we know that square roots cannot be negative, it means that there's no possible real solution to this. So our answer is no real solution. Number 3, solve the quadratic using square roots once again. So we're going to start by taking the square root to cancel those out because we have to work from the outside in. So 3x plus 2 is equal to positive or negative 6. The square root of 36 is 6. So from here I'm going to split it because I know that I have two possible answers here. So I've got 3x plus 2 is equal to 6, or 3x plus 2 is equal to negative 6. And I'm going to solve each of those. Subtract 2 from both sides. 3x is equal to 4 divided by 3. X is equal to 4/3. Or, I'm going to subtract 2 from both sides. 3x is equal to negative 8. Divide 3 on both sides. And we get x is equal to negative 8/3. And so there's my two solutions for number 3. Number 4, given the quadratic equation, find the solutions of the equation using the quadratic formula. So we talked about in class that I don't care what method you use as long as it works. However, for the test, if it gives you a specific method to use, make sure you use it. If it just says solve it however you feel like it. So if we're going to solve 2x squared minus 6x equals 8 using the quadratic formula, I need to be equal to 0. So I'm going to subtract the 8 from both sides. So 2x squared minus 6x minus 8 is equal to 0. And now I can identify my a term, which is 2, my b term, which is negative 6, and my c term, which is negative 8. Now we know that the quadratic formula is x equals negative b, which is negative 6, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. From here we're just going to simplify. X equals, that's going to be 6 plus or minus. I'm going to use my calculator for the inside of this to get 36 plus 64 gives me the square root of 100 all over 4. And then I know that the square root of 100 is 10. So 6 plus or minus 10 over 4. And now we're going to split this into two separate equations. The x is equal to 6 plus 10 divided by 4. And x is equal to 6 minus 10 divided by 4. Well, 6 plus 10 is 16 divided by 4, which is 4. And 6 minus 10 is negative 4 divided by 4, which is negative 1. So my final solution for this problem is x equals 4 and negative 1 are my two solutions. Alright, moving on, number 5. So, your classmate uses the discriminant to determine that the equation has two real solutions. And then you're given a set of numbers, 5, -3, 2, -5, 3, and -2. And part A says use those values to show that your classmate's claim is true. So if it's true, we want two solutions. Well, if we remember from our notes, first of all, the discriminant was b squared minus 4ac. It was the underneath of the radical. And we had three rules. If b squared minus 4ac was greater than 0, we had two solutions. If b squared minus 4ac was equal to 0, we had one solution. And if b squared minus 4ac was less than 0, we had 0 solutions. So if I want the claim to be true, I need to pick values for A, B, and C that give me two solutions, which means I need that to be greater than 0 when it's all done. Alright, so how do we do this? Well, the easiest thing we can do is make sure that since we're subtracting, that this B term is bigger than this 4AC term. That's the easiest way to make sure it's going to be positive. Or, if these are both positive values, so if this b squared is positive and this 4ac is positive, then it doesn't matter because we're adding two numbers, and anytime you add two positive numbers, it's going to be another positive number. So the good news is I can pick b to be whatever I want, because if I'm squaring b, it's always going to come out to be positive. So over here on the side, I'm going to write down a, b, and c, and I'm going to just pick something from this list. You might have to do some trial and error. For B, I'm just going to pick a 2. No reason other than I just felt like picking a 2. Okay? Now for A and C, I want to try to make this 4AC, this whole negative 4AC right here, a positive number. So if I already have a -4, and then I'm multiplying it by two more things, the only way that I can ensure that this whole term becomes positive is if either A or C is positive, not both. If A is positive, if A is positive, then, and I make C negative, then it's going to be negative times a positive times a negative, which would be a positive. Or if I make A negative and C positive, it's going to be a negative times a positive, which is still going to be positive. So I just need to make sure that either A or C is positive and the other one is negative. So I'm going to pick for A, -3. And since I made A negative, I'm going to make sure that C is positive, so I'm going to make C a +3. And also, I didn't care what those values were, I just cared about the signs of those numbers. Now, if we go ahead and plug them in and check it, so it's going to be 2 squared minus 4 times -3 times +3. 2 squared is 4, and then -4 times -3 is +12. Times 3 is +36, which is exactly what I was looking for. Now I have two positive values, gives me 40, and 40 is greater than 0, so we get our two real solutions. Alright, working on part B, same thing, but this time we want it to be a false statement, which means I want to show that I either get one solution or 0 solutions. Now, one solution is only going to happen when the discriminant is equal to 0. It might be kind of difficult to pick numbers that cancel each other out so that the b squared is equal to the 4ac. So instead, let's work on getting no real solutions. And we get no real solutions when the discriminant is less than 0. So I want a negative value under the square root. Or I want a negative value when I subtract those. So b squared minus 4ac. So if we look at this, we know that b is going to be positive no matter what. And then 4ac could either be positive or negative depending on what I pick. It's negative right now. So what I want to do is I want to pick values of a and c that make sure that this 4ac has a larger value than b, so that when I subtract, I get a negative answer. So what I'm going to do, again, A, B, and C, and I want to make this as easy as possible, so I'm going to pick the smallest thing possible that I can for B. So my choices are 2s, 3s, or 5s. Now we know that the sign doesn't matter for B because we're going to square it, so it's going to become positive either way. So I'm going to pick a 2. Now let's go with a -2 this time for B. So I'm going to be a -2 because that's the smallest thing I can possibly pick, because no matter what I do, if I square that, I'm going to get a 4. If I square 3, I get a 9. If I square 5, I get a 25. So 2 or -2 is the best choice for that. Minus 4. Okay, so now we want to make sure that the 4ac is a negative number. So we already have -4, and we want to multiply it by something to ensure it stays negative. So if it's already negative, I want to pick either 2 positive numbers to put here to keep it negative, or 2 negative numbers to put there. Again, it doesn't matter what we pick, just pick something and check it. So if I've already used the -2, let's go with, let's make A -5. So if A is -5, then I need C to be another negative number, and the only other negative number that I have left is a -3. And now I can check my work. So I get 4, and then in here, it's going to be -4 times -5, which is positive 20. Positive 20 times -3 is -60. And now we can see for sure that it's 4 minus 60, which is -54, which is definitely less than 0, which shows that my classmate is wrong. All right, number 6, solve by completing the square. So typically we only complete the square, we talked about in class that we only want to complete the square when A is 1 and B is even. Unfortunately for this problem, they decided that they want us to complete the square when B is odd. That's okay though, it just means we're going to get a fraction. A is even, or A is 1, which is good. Our constant is already on the other side, so we're going to go ahead and start with x squared minus 3x, leave some space, and it's equal to 8. And this is where we complete the square by adding that b term over 2 squared to both sides. So we add -3 over 2 squared to each side of the equation. Now we know that this left-hand side is always going to factor. We make it this way so that it factors to be x and whatever is inside that parentheses, that b over 2. So it's going to be -3 halves. And that's equal to 8 plus 9/4. If you're wondering how I got the 9/4, I squared -3 to get 9, squared the 2 to get a 4. So now I have x minus 3 over 2 squared is equal to 8 plus 9/4. You can use your calculator if you'd like to. I get 32 over 4 plus 9 over 4 with a common denominator, and I get 41 over 4. Alright, now we're going to solve this. We're going to get rid of that square by taking the square root of both sides. So x minus 3 halves is equal to plus or minus. I don't know the square root of 41, so it stays, but I do know the square root of 4, which is 2. Now I'm going to add the 3 over 2 to both sides, and that's going to give me x equals 3 over 2 plus or minus the square root of 41 over 2. There's my answer. If I wanted to, because these had the same denominator, I could write that as 3 plus or minus the square root of 41 all over 2, one giant fraction. Both are correct. Alright, moving on to number 7. It's going to look a little bit different on your test. It's just going to be given, it's the same type of question. You're going to be asked to pick a method and the reason for that method, but it's just going to be some blank space where you need to write in what your method was with an explanation. But on the review, I'm giving you the methods, I'm giving you the reasons, so you know what we're looking for. So for each of these problems, we're going to pick the appropriate method. We know that some of these problems have multiple ways to solve them. That's fine, as long as your method and your reason are accurate. That's all I'm going to care about. So the first one, 3x squared minus 9x, what's the method? Well, I can't use square root because we can only use square root when we're missing b. I could complete the square, but we only want to complete the square when a is 1 and b is even. I know I can always use the quadratic formula, and then there's factoring. If I look at that problem, we notice that both terms have a 3 and an x that we can pull out. So we can factor this. So the method is factoring, and why can we factor it? We can factor it because the polynomial is factorable, which would be reason D. What else could we do with this one? Well, we could obviously use the quadratic formula, because we can always do that, and that reason would be because it always works. Alright, the second one, x squared plus 6x plus 11. It is not missing a b term, so it can't be the quadratic formula. So it can't be the square root. A is 1 and b is even, so we could complete the square. What about factoring? Well, if we try to make the big X for the factor, we have 11 and 6. The only thing that multiplies to 11 is 11 and 1, but there's no way that 11 times 1 is going to be 11, while 11 plus 1 is 6. That doesn't work, so we can't factor it. So we can either use the quadratic formula or completing the square. I'm going to say this is a great opportunity to complete the square because a is 1 and b is even. The third one, x squared plus 2x minus 8. Again, we can complete the square on that because a is 1 and b is even. If I make the big X, I get negative 8 and positive 2. And if I think for just a second about it, I see that 4 times negative 2 would be negative 8, and 4 plus negative 2 is positive 2. So this one is factorable, or to complete the square. If it's factorable, it's because it's factorable. If it's completing the square, it's because a is 1 and b is even. So that one has multiple correct answers. Alright, the fourth one, 1.1x squared minus 2x plus 6.2. As soon as I see this, I notice that I have some decimal numbers in here. Once I have those, I'm going to go straight to the quadratic formula, because once we have decimals or fractions in the original problem, that's pretty much the only thing we can do. And finally, the last one, 2x squared minus 72. I'm missing a b term. And when I'm missing a b term, the first method we always want to try is the square root method, because when b is 0, that's when we do the square root method. Alright, what number is this? This would be number 8. Okay, so I'm given a function, x squared plus 2x minus 8, and they graphed it for us as well. And we're asked to do a couple different things. In part A, we're asked to determine whether the graph is increasing or decreasing in each of these intervals. So what does increasing mean? Increasing means the graph is going up as we move across. Decreasing means the graph is going down as we move across. So when x is less than negative 4, so here's negative 4 for x. When x is less than that, we're over here somewhere. So we're way up here on the graph, and which way are we moving? We're moving down, because we always read the graph from left to right, so our graph is moving down. So we are decreasing. And then from negative 4 to negative 1, well, here's x equals negative 1, which is way down here. So my graph is continuing to decrease. And then when x is greater than negative 1, so now we're moving that way as we move across the graph, and we are increasing. And then for part B, it seems like the same question almost, but it's a little bit different. For each interval in the box, determine if f of x, which we know that f of x is y, if y is positive or negative. So we're looking at the y values. So when x is less than -4, so again, here's -4, when x is less than -4, is y positive or negative? Well, when I'm less than -4 for x, it means I'm left, which means I'm up here on the graph. If we're above the x-axis, y has to be positive. Now, when x is between -4 and +2, -4, +2, my graph is completely below the x-axis, which means we are negative. And then when x is greater than 2, we're up here again. We're back above the x-axis, so we are positive once again. All right, number 8. Dan shoots a basket, just as it's shown in the picture. The function models the height in feet of the ball after t seconds. How long is the ball in the air before it hits the basket 9 feet off the ground? Well, the first thing we're going to do is we're going to take our equation, negative 8.5 t squared plus 18.5 t plus 6, and we're going to set it equal to the height that we want, which is 9 feet. And then that looks like a quadratic equation that we can solve. Move the 9 to their side. So negative 8.5 t squared plus 18.5 t is minus 3 is equal to 0. And we can do the quadratic formula. Very limited on space, so I'm going to kind of condense my work a little bit. A, B, and C. So I have t is equal to negative 18.5 plus or minus the square root of 18.5 squared minus 4 times negative 8.5 times negative 3 all over 2 times negative 8.5. And then I know that because those are decimals, I'm just going to get a whole bunch of decimal answers. So I'm going to use my calculator and make sure I'm going to take the square root of actually use the calculator to take the square root of the inside. So the square root of 18.5 squared minus 4 times negative 8.5 times negative 3 is 15.5. And that's all over negative 17. When I split that, I get t equals 0.1765 and t equals 2. So I went ahead and used my calculator and did negative 18.5 plus 15.5, divided that by negative 17, and then I did negative 18.5 minus 15.5 and divided that by negative 17 as well. So we have two positive values. Normally, when we do these types of problems, we see that one of them is negative and we ignore it. But we have two positive values, so we need to figure out how long is the ball in the air before it hits the basket. Well, it's in the air between 0.17 seconds and 2 seconds. So we need to find the difference between those. So it's 2 minus 0.1765, which gives me about 1.82 seconds before it hits the basket. Do not forget your units. Make sure we say that it's seconds. Part B, what is the maximum height of the ball? Well, for that, I'm just going to use the calculator. And I'm going to graph that function. So here's the function, negative 8.5 x squared plus 18.5 x plus 6. I don't need the 9 anymore, because that's just this function was just the actual path of the ball. And what is the maximum height of the ball? So I'm just going to find the maximum value. So if I'm looking at the max, it's 1.09 comma 16.1. This is t, this is h. So the max height is 16.1 feet. Again, make sure you put your units on there. Part C, what does the domain represent in this context? Domain is our x value, which in this case is t for time, which represents the time in seconds that the ball is in the air. Alright, number 9. Use the information to decide which quadratic function has the smallest maximum. So we're looking for the smallest maximum value. Remember, max and min, once again, those are y values. So the second function, they give us the vertex. They give us the maximum value. The value is at 3. So the max is 3. For the first function, I need to find that vertex. So I'm going to go back to my graph. I'm going to graph the function negative x squared minus 4x plus 5. I'm going to find the max, and that max is at negative 2, 9. So my max is 9 because I'm looking for the y value. So the smallest max is function 2. Alright, number 10. A portion of the graph of a linear function is shown. So we're given a linear function on a graph and we're given a quadratic function in a table, or not a table, just the function, but it's in vertex form. And we should remember that the vertex of that is going to be at 1, 5. And we have to use this table to compare the two. So, let's see. The y-coordinate of the y-intercept of f, so the y-intercept of f is right there, which is at y equals 6. And then the second side, the other side, we're going to compare it to the y-coordinate of the y-intercept of g. So to find the y-intercept of g, we're going to have to plug in 0 for x. So g of 0 is equal to 0 minus 1 squared plus 5. So we're going to get negative 1 squared plus 5, which gives me 1 plus 5, which is 6. So it's y equals 6 and y equals 6. Those two are equal. Now we're going to do the same thing, now this time for f of negative 1 and g of negative 1. Well, f of negative 1, I can't see it on the graph, but I can see that my slope is rise 1, run 1, rise 1, run 1. So if I keep working back, where am I at? F of negative 1 is going to be at 7. And if I evaluate g of negative 1, I get negative 1 minus 1 squared plus 5. This is negative 2 squared is 4. 4 plus 5 is 9. Which one's greater, 7 or 9? 9 is greater. And then the third one for this is the maximum value of f of x on the interval from 0 to 6. And the max on g of x from 0 to 6. So on f, we can see that the maximum, remember that's a y value again, from 0 to 6. So we're just looking at this part of our graph right here. Our maximum y value happens to be at that y-intercept, which is at 6. On g, we're going to have to find that by looking at a graph. So I'm going to go to my graphing calculator. And here's that function, x minus 1 squared plus 5. My window goes from 0 to, mine's actually going to 8. So 6 is right here. So I'm looking at this little window, like this little, kind of this little space right here from where my cursor is to the x-axis, or to the y-axis, and then down that little box. Well, that output right there, so it looks like this graph is kind of a 5, 10, 15, 20, 25, 30. When x is 6, y is 30. That's my maximum value. And I know it was my maximum because when I look at the graph, everything else is smaller than that on either side. So comparing 6 to 30, 30 is bigger than 6. Number 11, what is the average rate of change? over the interval 2 to 5. So the interval, those are x values. Rate of change, that's slope. This is old stuff. How do we find slope? It's y2 minus y1 over x2 minus x1. So it's the interval 2 to 5. So I'm looking from the x value of 2 until the x value of 5. Well, those points are 2, -10 and 5, 0. So if I plug stuff in, I'm going to say 0 minus -10 over 5 minus 2. That's 10 over 3. So my average rate of change is 10/3. And then finally, the last question, number 12. This is similar to number 10. We are given a graph of f of x and a table for g of x. And it says compare the y-coordinate of the y-intercept of f of x to the y-coordinate of the y-intercept of g of x. So for f of x, again, I can see my y-intercept is at 0. For g of x, I know my y-intercept is when x equals 0, which is this point right here, which is at 4. So the second quantity is larger. For f of -1, well, I can read the graph. -1, I go up. I see that's at 3. For g of -1, I can see it on my table. It's also 3, so those are equal. And finally, the max of f of x on the interval -5 to 0 and the max on the interval -5 to 0. So the maximum value from -5 to 0 is going to be right here at the vertex, which is 4. And then the max on -5 to 0 over here. So -5 actually isn't on my table. It'd be this next point, but we can see that we're decreasing. So that would be at -1. So what's my largest y value? It's going to be this +4 down here. So once again, those are equal. And that's going to be it for the review for the quadratic equations unit for Algebra 2 Honors.